Alright, welcome back everybody. In this video we're going to talk about vector operations. We start with a little bit of narrative up here as far as what a vector is and how we write vectors. And we're going to move right here directly into example 1 to show that these two vectors u and v are equal. Now in order for two vectors to be equal, they have to have two things in common. They have to have the same length and the same direction. Okay, so we're trying to show here that the vectors AB and CD are equal to one another. So the first thing I'm going to do is I'm going to find the length of the vector AB. The length of the vector AB I'm going to find by using our distance formula. Got 2 minus 4 squared plus 5 minus negative 3 squared. And if I go ahead and do those calculations, that's negative 2 squared plus 8 squared. And the length of AB is the square root of 68. I'm going to do the same thing to find the length of the vector CD. And so I've got square root of negative 3 minus negative 1 squared plus 4 minus negative 4 squared. And that gives me, again, the same exact value, square root of 68. So these vectors are the same length. It's not yet enough to show that they're equal vectors. The other thing we need is for them to be in the same direction. Now, how do we determine and describe the direction of a vector? We can determine and describe the direction of the vector as the slope moving from the initial point to the terminal point. And so I find the slope of vector AB, and that's going to be 5 minus negative 3 over 2 minus 4. It's going to be 8 over negative 2, or negative 4. And the slope of the vector CD is going to be negative 3 minus, sorry. It's going to be 4 minus negative 4 over negative 3 minus negative 1. And so the slope of that vector is also negative 4. And you can see that we're, if you think about these two vectors, you've got the vector AB, which goes from the point 2, 5 to the point 4, negative 3. It looks like this. And the vector CD, which goes from the point negative 3, 4 to the point negative 1, negative 4. These vectors are the same length and they're traveling in the same direction. Alright. Component form of a vector. We talk here about component form of a vector. You're going to want to read through that narrative. And we also talk about the magnitude of the vector. The magnitude is simply the length of the vector, and it's notated with absolute value bars around the vector. So let's start with the component form of the vector AB. Okay. So what happens with our x-coordinate as we move from point A to point B? It's negative 2 units less. And our component form as we move from 6 to 3, it's 3 units less. And so the component form of this vector is negative 2 comma negative 3. And this is basically what happens if I would transfer point A and move it to the origin. Where would point B move if I slid that whole vector and moved point A over to the origin? Well, I moved it up 2 units to the origin and or right 2 units to the origin and down 6 units. So I moved this point right 2 units and down 6 units. And that gives me my terminal point and my component form for this vector. As far as the magnitude of vector AB, the magnitude of vector AB is just going to be the length of this vector. So we're going to take the square root of -2 squared plus -3 squared. And so the magnitude of this vector is the square root of 13. So there's my component form and my magnitude of vector AB. Find the component form of the vector V of length 6 that makes an angle of 55 degrees with the positive x-axis. So we've got this vector. It makes an angle of 55 degrees with the positive x-axis, and the length of this vector is 6 units. So in order to find the component form of said vector, we're going to use right triangle trigonometry. The x component is just going to be the length of the vector times the cosine of the angle, and the y component is going to be the length of the vector times the sine of the angle. And so the component form of this vector is going to be 6 cosine of 55 degrees, 6 sine of 55 degrees. And I'm going to go ahead and just calculate those. We'll get approximates for them. So we've got 6 cosine of 55. Alright, where's my degree symbol on this calculator? Do we have a degree symbol? Or do I have to switch modes? I don't see a degree symbol anywhere on here. So I'm going to go in and switch my mode over to degree mode. Maybe it's there and I'm just overlooking it right now. We get 3.441 and 6 sine of 55, 4.915. And there's the component form of a vector with magnitude 6 that makes an angle of 55 degrees with the positive x-axis. Alright, that's where we're going to stop on this video. We'll come back in the next video and look at example 4 from this lesson on vector operations. See you guys then. Have a great rest of your day.